Good evening, my friends. We welcome you to our public address this evening, where we plan to explore what the Bible teaches about creation, how God has designed it and planned it. Our speaker for this evening, Mr. Jamin Hunter, who is to talk to us to the title Creation, Proof of Divine Design. He has asked that we preface his remarks with a Bible reading, and that reading is to be Psalm 8. That reading then serves to introduce the remarks of our speaker, Mr. Jamin Hunter, who will deliver his prepared remarks on creation, proof of divine design.
Well, thank you, Mr. Chairman, and good evening, everyone, and thank you for coming out tonight and hearing what we have to say on the topic of how creation is proof of divine design. The Bible starts with the book of Genesis, and the book of Genesis starts with Genesis chapter 1. And verse 1 of Genesis chapter 1 says that God created the heavens and the earth. And that is quite a bold statement these days because it entails a certain view of the world. If you believe that statement, you believe that there is a supernatural divine being, and that supernatural divine being not only has the power to create the universe and everything in it, but he actually did so. And that's something that people have believed to be true for all of history. For as far back as we have any form of recorded history, people have believed that to be true. But in today's Western society, we find that this belief is firmly opposed by a belief in a more naturalistic worldview. And so we have these two origin beliefs, these two worldviews for how the world came into being, how the world came into existence. And on the one hand, we have the religious belief, and this is the belief that there's a supernatural creator who created the earth, the universe, and everything in it. And on the other hand, we have the naturalistic belief. And that naturalistic belief it's the belief that the natural laws, the laws of physics, the laws of chemistry, those natural laws are sufficient to explain the origin of the universe and are sufficient to explain the origin of everything that's inside the universe. And of course, the outcome of that naturalistic belief, at least as far as biology is concerned, the outcome of that belief is the theory of evolution, which I'm sure many of us are familiar with. But of course, if you only believe in natural laws, if you take this naturalistic worldview and you only believe in natural laws, then you can't believe in a supernatural creator, because a supernatural creator isn't natural, and so he simply doesn't fit those parameters. And so it's important to understand that both these ways of thinking involve some kind of basic belief. The naturalistic worldview doesn't believe in a creator, not because of any proof that he doesn't exist, but simply because the naturalistic worldview believes that there's nothing beyond the natural laws of physics. So the rules of the philosophy just don't allow there to be a creator at all. Well, as Christadelphians, we're firmly convinced of the truth of the biblical record, but in these modern times, we increasingly find ourselves required to explain how we hold that belief when so many people in the world around us take the naturalistic evolutionist worldview for granted. And so that's what this lecture is about. And of course, there are many ways that we can and we do justify our beliefs, and there's a list of them here. There's the internal consistency of the Bible, there's fulfilled prophecies, there's archaeological evidence, there's historical evidence, and there's evidence for intelligent design, or what we might call the intelligent design hypothesis. And of course, there may be others on that list. I haven't tried to make it exhaustive. But the intelligent design hypothesis, the evidence for intelligent design, is what we're going to focus on tonight. And that's particularly relevant to this question of evolution or creation or the origin of the world. And this hypothesis, this is the idea that all the phenomena we see in the natural world around us, the organisms, the ecosystems, all of those phenomena are best explained as the work of an intelligent designer. That is the best explanation we can come up with to say, how did these things come into being? And so that's what we're focusing on in this lecture. And one thing that's particularly powerful about that hypothesis is that it isn't necessarily a religious argument, it's a scientific one. And so it takes the scientific methodology of the naturalistic worldview and essentially stabs it with its own sword. And so just to give you an example, if I go outside and I see a brand new Porsche sitting in the car park, there's certain properties of that object that lead me to conclude that it was designed and built by someone and that just didn't happen there by chance. It's got a lot of interrelated components that are all very specialised. They're all clearly designed to do a specific job and they all fit together very nicely. Let's suppose now that I go out into the car park and instead I see a monarch butterfly sitting on the tree. Well, I can use the same properties of this butterfly, to infer that it was designed and built by someone, because it's got very similar properties to the Porsche, with this idea of all these components being connected together and clearly being designed by someone to fulfill a specific purpose. And so it's not necessarily a religious argument, it's a scientific one. We can observe the effects of intelligence in the natural world around us. We can observe the effects of intelligence in the non-natural world around us, in things like Porsches and clocks and computers. And we see the effects of design in the non-natural world. And then when we look at the natural world, we see similar effects there. And so we infer a similar cause. We infer the cause of design. And so, as I said, it's not necessarily a religious argument, but we believe that it does have religious implications. And this is a line of thinking that is supported by the Bible. And so what we're going to do now is look at a list of quotes, just briefly, which take the works of creation. They look at the works of creation and they use those as evidence for the power and the wisdom and the greatness of the Creator. And the first one we'll look at was from our reading tonight, Psalm 8, verse 3 and 4. When I consider thy heavens, the work of thy fingers, the moon and the stars which thou hast ordained, what is man that thou art mindful of him, and the son of man that thou visitest him? If you turn up Psalm 19, verse 1, we have a similar idea there. Psalm 19, verse 1, the heavens declare the glory of God, and the firmament showeth his handiwork. And so once again, there's a similar idea. The psalmist here is looking at the creation, looking at everything that God created and saying, well, I can see these things that God has created and they are evidence to me that there is wisdom in these things, that there is wisdom in the Creator. Another psalm, turn over to Psalm 139 and verse 14. Psalm 139, verse 14. I will praise thee, for I am fearfully and wonderfully made. Marvellous are thy works, and that my soul knoweth right well. So here the psalmist is looking at his own body and saying, I'm fearfully and wonderfully made, and whoever made me, whoever created me, is clearly worthy of praise. Another quote that we might turn up is in the New Testament, if you come to the book of Romans chapter 1. Romans chapter 1, and we'll start in verse 18. And it says in verse 18, for the wrath of God is revealed from heaven against all ungodliness and righteousness of men who hold the truth in unrighteousness. And now this translation can be a little hard to follow, so we might look at what the NIV says. It says, it's revealed from heaven against all ungodliness and unrighteousness of men who by their unrighteousness suppress the truth. For what can be known about God is plain to them, because God has shown it to them. For his invisible attributes, namely his eternal power and divine nature, have been clearly perceived ever since the creation of the world in the things that have been made, so they are without excuse. And so what Paul, the author of Romans here, is saying is that people can see the evidence of God's power. People can see the evidence of God's divine nature in the creation, in the things that he has created. And he says they are therefore without excuse. And so in all of these quotes, people are looking at the creation, looking at the things that God has created and saying, when I see these things, there is evidence for the wisdom and the power and the greatness of God. And that's essentially what we're going to do tonight in looking at the evidence for intelligent design. It's pretty much exactly the same argument. And so what we're going to do now is go through a list of 4 key arguments for the existence of an intelligent creator. And I've tried to make sure this lecture has something for everyone, so these arguments will get progressively more sophisticated as we go along. And I'll try to explain them in a straightforward manner, but I do apologise in advance if I lose anyone. So the first argument we're going to look at is just the straightforward inference to design. Or in other words, we can see the designs in the natural world and they bear many similarities, similar properties to designs that are produced by human intelligence. They bear the marks of an intelligent creator. So what are the marks of an intelligent creator? Well, the first one you might think about is organisation. If you open up a phone, look inside a phone or any other piece of electronics, you'll see that it's organised into a range of components. And all of these components are complicated and specialised, and each one serves a particular purpose. And if you take out one of those components, then the phone just doesn't work as well anymore, or it might not work at all. If you open up a human instead, you'll see a similar thing. It's arranged into a range of components, and each one of those components serves a specific purpose. It's a range of different organs, and they're all very neatly laid out. Each one is in its proper place, and each one is serving a specific purpose. And there's clearly been thought put into where these components are. The lungs and the heart are in the centre of the body, where they're protected from damage, and that way they can easily supply blood and oxygen to the rest of the body from a central location. And you'll notice that you won't find any additional lungs randomly floating about. You won't open up someone's leg and find an extra lung in there that's not connected to anything. It just doesn't happen. And there's no pointless components in here either. The people who believe in the theory of evolution are very keen to point out that some parts of the body seem to be useless. They once thought that the appendix was useless, and they said, well, it's a leftover part from evolution. It was needed by some of our ancestors back in the deepest, darkest ages, but it's not needed now. But as we've found out with the recent discoveries from modern science, in fact, the appendix does serve quite a useful purpose. It serves as a home for many important types of bacteria, and those bacteria live in our intestines and they keep our intestines healthy. And we actually know now that people who've had their appendix removed have a significantly higher risk, sometimes 12 times higher risk for certain types of cancer. So it doesn't really seem like the appendix is as useless as some people might think. And so that's the argument from organisation. We see similar types of organisation in human and in natural designs. The next argument, the next point we might look at is interdependence. And again, we'll use the analogy of phone. A phone doesn't just work in isolation. It's part of a complex web of devices. You've got your phone chargers, you've got Wi-Fi networks, phone towers, there's car entertainment systems, which usually a phone will connect to those these days as well. And all of these things are highly complicated and they have highly complex interactions. And they don't just work together because they're thrown together. They have to be specifically designed to be compatible. And when we look at natural ecosystems, we see the same complex webs of interaction. If you think about the thousands of complex interactions that happen in a rainforest, there's trees that provide food for small animals, and in turn those small animals provide food for large animals. There's ants and other insects who live on the ground and they feed on the dead plant matter. And so they get their food from that, but in turn they cultivate bacteria, and those bacteria help to break down the plant matter and they produce nutrients which then leach back into the soil and help to keep the soil healthy. So all of these many thousands, and we can go on ad nauseum and list all of the many thousands of interactions that happen in a rainforest ecosystem, but all of them work together to maintain that ecosystem. It's a highly complex system. An interesting example is beavers. Beavers build dams in wetlands, and from the beaver's perspective, they build a dam to help protect themselves from predators and really to give themselves a place to live. But what we find is that that's not all that dams do. The dams that the beavers build play a huge role in promoting the health of the ecosystem. And so there's a recent BBC article that went into this, and quoting from this article, there's a study by Finnish researchers in 2018 that found that ponds engineered by beavers contained nearly twice as many mammal species as other ponds. Weasels, otters, and even moose were all more prevalent. Anyone can make a pond, but beavers make amazingly good ponds for biodiversity, partly because they're shallow, littered with dead wood, and generally messed about with by beavers feeding on plants, digging canals, repairing dams, building lodges, etc. And then quoting the researchers, basically, beavers excel at creating complex wetland habitats that we would never match. So think about the beaver himself. He doesn't understand biodiversity. He's got no idea about any of this. Nobody taught him to build dams either. All he's doing is doing the job that he was designed to do by his creator, and yet he forms part of this highly complicated system where everything he does promotes a complex web of interactions that keeps the ecosystem healthy. And so everywhere we look in nature, we see this evidence of design. And what we see is that not only does it remind us of human design processes, in many cases, in fact, in probably all cases, it's vastly superior to anything that we could ever design ourselves. So we've looked at organisation, we've looked at interdependence, and they're two hallmarks of design that we see in the natural world and in human designs as well. And another one we could look at is a deep understanding of the physical world. And to explain, let's again use the analogy of a phone. If you think about a modern smartphone, it doesn't just happen. It's designed by thousands of specialists, and these specialists are all working together. And each one of these specialists has a deep understanding of a particular topic, and they bring all of those topics together. So you've got a very wide range of subjects. There's quantum physics, there's chemistry, there's materials engineering, there's electrical engineering, there's computer science, there's industrial design. And of course, we could go on and go on and go on. To produce a modern smartphone, you require a very deep understanding of each of those subjects. And when we look at the natural world, we see in the designs in the natural world a similar understanding of the laws of physics and chemistry and all other kinds of fields that we might study. And yet, let's use the example of a dragonfly. And there's quite a few different areas we could delve into. We could look at the materials science that went into designing its wings. We could look at the quantum physics that you would have to understand to be able to design its compound eye. But perhaps let's look at how it flies. You might think that dragonflies just flap their wings up and down, like you might flap your arms. It doesn't work too well for you if you just flap your arms up and down, and it wouldn't work too well for the dragonfly if it just flapped its wings up and down either. The way a dragonfly flaps its wings is actually extremely complicated. It uses a very precise flapping and twisting motion, and as it turns out, this is actually a very efficient method of flying. And it's very different to how aircraft fly. In fact, it's so different that up until the 1990s, scientists couldn't explain how insects could fly at all. The scientists would look at how an insect's wings move and then do all of their mathematical analysis, and they'd eventually come to the conclusion that it was impossible. The insect couldn't fly, except, of course, the insect can fly. And since then, they've done a bit more analysis, and they've worked out that the way an insect flaps its wings actually produces special airflow patterns that look a bit like that. It's almost like mini whirlwinds around the insect. And so the very complicated motion that it engages in when it flaps its wings produces these special airflow patterns. And these wings, this method of flying, it's actually the most efficient method of flying for an object that size. Those wings produce 10 times more force. When you consider their size, they produce 10 times more force than the equivalent plane wing. And since the 1990s, designers have been working hard to mimic insect flight by trying to replicate the flapping and twisting action of their wings. However, this has turned out to be incredibly difficult, mainly because of the high speeds involved. In addition, engineers have been unable to fully understand the aerodynamics of insect flight because the airflows are so complex. This was a quote from an engineer who tried to build a robot that would mimic the way this dragonfly flies. He says, engineers have been unable to fully understand the aerodynamics of insect flight because the airflows are so complex. And he concluded, consequently, the best way to produce an insect-like air vehicle is to copy an insect as closely as possible. And that's essentially what he did. He tried to copy the dragonfly because he couldn't improve on the design. But when we look at these things, we're forced to the conclusion that whoever designed this dragonfly had an incredibly advanced understanding of fluid mechanics, of aerodynamics, far more advanced than we ourselves. And so this is the argument of inference to design. We can point to similarities between the natural world and human-designed objects. We can see the effects of human intelligence in human-designed objects. And we can therefore infer that these natural objects were also designed. But of course, that almost does them an injustice because the designs that we see in the natural world are invariably far more complicated than anything we could have created ourselves. And so that was our first argument, the design inference. And that is a powerful argument, and anyone who wasn't biased against belief in a creator would probably find it convincing. But of course, evolutionists like to argue. And if you present them with this sort of evidence, they would usually say something along the lines of, well, yes, these are wonderfully complex designs, aren't they? But they've been evolving for billions and billions of years, you know. They started out very simple and they gradually improved step by step until they became highly complicated. Well, there's a big problem with that. Perhaps the biggest problem is that if you do any serious kind of mathematical analysis, you quickly find out that it's impossible. Even if you have billions of years, you simply can't evolve systems like this in that amount of time. But there's a more interesting argument that we can use against that, and that will be our second argument for tonight, and this is the idea of irreducible complexity. So if we think about how evolution is supposed to work, it starts off with something very simple, something very small and simple, and it builds on it piece by piece and gradually improves it until you eventually form something complicated. But the big problem with that is that it isn't hard to find designs in the natural world which are irreducibly complex. And what we mean by that is they need all of their pieces there, they need all of the pieces together at the same time, otherwise they don't function at all. And so you can't build it up step by step, piece by piece, because if you don't have all the pieces all at the same time, then it just doesn't function, it just doesn't work. If you think about it a bit like a mechanical watch, if you've ever opened up a mechanical watch, you'd see that it's full of hundreds and even thousands of incredibly intricate pieces. And they all work together, and they all need to be in the same place, in the right place at the same time for the watch to have any function at all. And if you leave one of those pieces out, the watch becomes nothing more than a very expensive paperweight. And so we can find examples of irreducible complexity when we look even within our own bodies. And so we previously looked at whole organisms, beavers and dragonflies. What we're going to do now is zoom in. And tonight we're going to zoom in several times, but for now we're going to zoom in and look at cells. As most of you would probably know, if you put a living organism under a microscope, you'll find that it's made up of a huge number of tiny cells, all of these little components that are all joined together to make a human or a beaver or a dragonfly. And in this case, those happen to be plant cells, but if you put a human under a microscope, you'd see something quite similar. And it was once thought that these cells were quite simple. They were just little bags of fluid, and they're all joined together to make a human. And of course, that's not the case. With the benefit of modern science, we now know that these little cells, these tiny building blocks, in themselves, they're incredibly complicated little devices. They're not just sacks of chemicals, they're actually factories, and they have an incredible array of machinery. And that machinery is irreducibly complex. And so there's machines inside these cells, and these machines aren't made of bolts and pulleys, conveyor belts. These machines are made of tiny molecules. One example we could look at is the bacteria flagellum motor. And this is a machine that we see in certain species of bacteria, and it's essentially a motor which drives a propeller and it allows the bacteria to swim around. And as you can see, it looks just like a human-designed motor. It has all of the components you'd expect to find in a human-designed system. There's a rotor, there's a stator, there's bearings, and there's a clutch. Quite similar to a human motor in some respects, but unlike a human motor, it assembles itself from scratch. And unlike a human motor, it has mechanisms to repair itself. And it can rotate at up to 100,000 revolutions per minute. And despite going that fast, it can also stop and reverse and go in the opposite direction, and it stops within 1/4 of a turn. And most importantly for our argument tonight, it's also irreducibly complex. If you remove just one of those components, the motor doesn't work and the bacteria doesn't survive. And in one species of this bacteria, there's 35 different genes that combine to produce this motor. And scientists have done a series of experiments where they'll turn off one gene and see how the bacteria goes, and then they'll turn off the next gene and see how the bacteria goes. And they go on like that for all 35 genes. And what they found is that all 35 genes are essential for the motor to function. And so if you want to explain how this bacteria evolved, how this motor evolved, you've somehow got to explain how all of those genes just happened to come together in the same place all at the same time. And of course, remember that chance evolution has no idea what a good motor looks like. There's only one process that we've ever observed that has the foresight and the understanding to piece together a design like that, and that process is intelligence. And there's another example. It's quite an interesting little chap, isn't he? And it's worth pointing out that he has several essential components. He's got 2 feet and he's got a head. And of course, there's the microtubules that he walks along. And if any one of those components was missing, then the kinesin wouldn't work and the cell would cease to function. And of course, you, being made up of many trillions of these cells, would cease to function as well. And it's also worth emphasising just how small these things are. In the case of the flagella motor, it's about 45 nanometres wide, which is to say you could fit 22,000 of them between the millimetre markings on a ruler. The human body is made up of around 30 trillion cells. And that means if you hold your hand up in front of your face, you're looking at more cells there than there are people on the face of the earth. And what you saw in that video is going on in each one of those cells. So the argument from irreducible complexity is quite convincing, but there's another one that we can look at, and that is this idea of abiogenesis, or could life spontaneously arise? Because evolutionists like to talk about how living species have supposedly changed and evolved over time. But perhaps the biggest problem with that is that evolution can't happen at all until we have some form of living organism to start with. And that means you have to somehow have a cell spontaneously come into existence by pure chance. And that idea is known as abiogenesis. And back in Darwin's day, when we just thought a cell was like a little bag of fluid, that might have seemed somewhat plausible, because they didn't know much about how cells actually worked. But that's not so much the case today, because as you've seen, we're starting to understand how incredibly complex these cells are. And this is quite an embarrassment for those who don't believe in an intelligent creator, because this idea of a cell just happening by chance, to put it mildly, it's impossible. And to get an idea of just how impossible, we're going to look at DNA. And so once again, we'll zoom in even further on the cell, and we're going to look at a DNA molecule. And you've probably seen a DNA molecule before, at least in a picture like that, the double helix structure it's called. And at the top there, we've got it uncoiled, so you can see both sides straight up. And you'll see it's made of a sequence. And you've got sort of the legs down the side here, and in the middle here are what are known as base pairs. And base pairs are made up of 4 molecules. There's adenine, thymine, guanine, and cytosine. And so as you go down the DNA molecule, you'll have one of these at each run. And so you can think of those 4 molecules, you can just abbreviate them to letters. So you've got A, T, G, C. And so if you think about, let's read down the molecule, we can read out essentially a sequence of letters. And that's what DNA is. It's a code. It's essentially a sequence of letters. And so to take away the molecule and just represent it like that, a section of DNA might look something like that if we're just reading out what the code says. Now, these codes, you can think about it, it's similar to how we make a code called English. We just string letters together, but they happen in words. And in DNA, when you're transcribing a protein, these words are 3 letters each. Now, cells have a lot of proteins inside them. It's one of the major things that a cell does. And these proteins are made up of what's called amino acids. They're just long chains of amino acids. And an amino acid is just like a chemical. And so you join a lot of these amino acids together into a chain and you make a protein. And then you join a lot of proteins together and you can make some of these molecular machines that we're talking about. And so each one of these words has a specific meaning. And to illustrate what I mean by that, let's look at this. The word CAT. So in English, that means a nasty little animal who lurks in your front garden. But in DNA language, that refers to the molecule histidine. And there's another example here. GGT is glycine. There's a diagram of that little molecule there. And GTG is valine. And so if we string those three words together, you get a string which might be a sequence of DNA. And we can start to understand now that this sequence of DNA is an instruction. It's an instruction to the cell, and it tells us string together a string with histidine, glycine, and valine all in a row like that. And so that's more or less how DNA works to create a protein. The important point to understand is that you can't just have any old string of DNA and expect it to work. You can't just generate random letters and expect it to mean something important. If we look at these proteins, they look something like this. And that's kind of like a stylized representation. But the important thing to understand is it's got this complicated 3D structure. And that 3D structure is what makes this protein actually do something. And so you can join these 3D structures together, for instance, to make molecular machines like the bacterial motor. But the thing is, if you just generate a random string of DNA and get a random string of amino acids, the chances are that it won't actually fold into those 3D structures, because that's actually a very rare property. So if you just get a random string of DNA, you can make that into amino acids, but it won't form a proper protein. It's just going to be loose and flop about, so it's not actually going to do anything. And of course, the problem with that is that, well, let's think about this idea of abiogenesis, a cell miraculously coming into existence by pure chance. If the cell comes into existence by pure chance, we can assume that all of the DNA in this cell is going to be random. And so that random DNA is going to produce random proteins, and those random proteins aren't going to do anything. They're not going to fold properly. They're not going to be of any use to the cell, and so, of course, the cell won't survive. It's actually extremely unlikely that if you get a random section of DNA that it's going to produce a functional protein. And the question is, how unlikely is that? Well, it's been estimated by a scientist who knows far more about this than I do. It's been estimated that the probability of randomly generating one medium-sized protein is approximately 1 in 10 to the power of 65. So that's that's a 1 with 65 zeros after it. And of course, that's just one protein. We need thousands, hundreds of thousands of proteins to make an organism like a human. But let's just say if there was 3 proteins, what's the probability of randomly generating 3 medium-sized proteins? That's 1 in 10 to the power of 195. We can express that as a 0 with a lot of zeros. And eventually we find the 1 at the end. So it's a very, 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 very tiny probability that would happen. But shall we try and get an idea of just how unlikely that actually is? If we think about, from the evolutionist point of view, how this is supposed to have happened, this cell has just happened to occur by chance inside the primordial soup. And so there's this protein that's been randomly generated. So let's give the evolutionists a little bit of help, shall we? How many atoms are there in the universe? It's estimated that there's 10 to the power of 82 atoms in the universe. Now let's say that for each one of those atoms we'll create a machine which generates random proteins, okay? And so obviously the idea is the more random proteins we generate, the more likely we are to find one that's actually going to be useful. And then, of course, we're on our way to evolving life, aren't we? So let's say we create these 10 to the power of 82 machines, and each one of these machines is going to spit out 1 million random proteins each second. And we're going to run these machines non-stop for 100 billion years. And of course, I would emphasize that 100 billion years is a ridiculous estimate. The outside estimates for the age of the universe are somewhere around 13, 15 billion years. So we're giving the evolutionists a huge amount of help, and of course this isn't realistic at all. So whatever probability we come up with is going to be far, far too generous to start with. But let's say we run these machines for these 100 billion years, we'll get a massive pile of proteins, all random proteins, and there will be 10 to the power of 107, approximately, proteins in that pile. And now we've got to sift through this pile, and we've got to find just 3 proteins in that pile, just 3, that are going to actually do something. How unlikely is it? There's 10 to the power of 107 proteins in the pile. The chance of finding 3 functional proteins in this pile is 1 in 10 to the power of 88, or 1 in 10 million, billion, trillion, 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 trillion. Of course, it's silly to try and get your head around numbers like this. It's just so ridiculous to think that it could happen by a chance. It's impossibly unlikely. And of course, I'd emphasise that that is a very, very generous estimate for the probability of just 1 step required for life to occur by chance. In reality, we would need thousands of steps, thousands of proteins, thousands of other factors to come into play to allow a cell to miraculously to allow a cell to come into existence by chance. It's just not going to happen. And of course, an evolutionist can say, well, perhaps it did happen by chance, but personally, I'd prefer to play the lottery. Well, one final argument that we might look at is this idea of fine-tuning. And this will be our final argument for tonight. And this is also a very powerful argument, because when we look at the laws of physics themselves, there is evidence of design within the laws of physics themselves. What we find when we look at the laws of physics is that they're very finely tuned, and if they were just tweaked slightly, if someone made just a slight change to how the laws of physics work, it would be impossible for life to exist at all, physically impossible for life to exist at all. And of course, that's a very powerful argument, is it not? Because the laws of physics are fixed, they're unchanging, so it's impossible to argue that they evolved in any way, because that's what we start out with. We start with the laws of physics. We can't get another chance at physics. We've only got one universe. So we zoomed in on the cell, did we not? And then we zoomed in on DNA. Let's zoom in even further and let's just consider one atom. These atoms, they're made up of protons and neutrons and electrons. Hopefully you can all read the diagram there. A proton has a positive charge, a neutron has no charge at all, and an electron has a negative charge. So let's just talk about protons and electrons, the positive and the negative side. These charges, it's a bit like the 2 different poles on a magnet. You know, a magnet has a north pole and a south pole. So if you get 2 magnets and put the north poles together, what happens? They push each other apart. There's a force of repulsion. On the other hand, if you flip it around, so you've got the north pole and the south pole, then there's a force of attraction. They draw each other together. And that's the same with protons and neutrons. It's called the electrostatic force. And so if you have a proton that's positively charged, an electron that's negatively charged, they draw each other together. But if you have 2 protons, they're both positively charged, it's like 2 north poles in a magnet, and they push each other apart. And that's interesting when we look at how this atom is structured, because this atom has all of its protons in the middle and all of the electrons around the outside, and that's how every atom is. Protons in the middle and electrons around the outside. The question is, how does this atom even stay in one piece? If these protons are all positively charged, they should all be pushing each other apart and the atom should explode. And of course, if we don't have atoms, we can't have life. How does this atom stay together? And the answer is that there's another force acting inside this atom, and it's called the strong nuclear force. And you don't need to worry about the strong nuclear force somehow making your house fall down, because this strong nuclear force only acts at very short distances, only within the nucleus of the atom. But this strong nuclear force pulls these protons together and it counteracts the electrostatic repulsion. And so it keeps the atomic nucleus together by pulling these protons towards each other. And so let's think about it like this. We've got these 2 protons inside the nucleus, and there's the electrostatic force that pushes them apart, and there's the strong nuclear force that pushes them together. If you think about it, these 2 forces have got to be in balance, don't they? If the strong nuclear force is too weak, then the atom is just going to fly apart. And of course, then we have no atoms and no life. What we find is that these 2 forces are in fact very, very finely balanced. if the strong nuclear force was very slightly stronger, if it was just 10% stronger, then the atoms would all merge together and they'd form useless blobs of neutrons. And of course, you can't make any life out of just neutrons. If, on the other hand, this strong nuclear force was very, very slightly weaker, then all of these atoms would explode. They would all fly apart. And the only atoms we would have left, it would just all be hydrogen. And of course, that would be just as useless as blobs of neutrons. And so you can see that these two forces are very finely, very delicately balanced against each other. And we can be in danger of taking that for granted. Just assume that these forces are as they are. But when you think about it, what reason is there? There's no reason why the strong nuclear force shouldn't have been 10 times stronger or even 100 times stronger than it actually is. And of course, if that's the case, then there's no chance of anything existing at all other than useless blobs of nothingness. How is it that this force has exactly the right value, exactly the right setting to allow complex organisms to exist? What about all of the other laws of physics? We could go into detail on them, but we don't have time. But how does it just so happen that all of the fundamental forces in physics, how are they all just set up that way? How is it that they're all finely tuned to allow life to exist? The only reasonable answer to that question is that they were designed that way by an intelligent creator who created the laws of physics as part of his design for the universe and everything inside it. So we've looked at 4 key arguments tonight, 4 key arguments for the existence of an intelligent designer. And number 1 was the similarity and superiority to human designs, and that implies that there must be an intelligent source, and that's what we call the inference for design. And number 2 is irreducible complexity. And when we see the examples of irreducible complexity in living organisms, what that means is that it couldn't happen by the evolution. It couldn't happen by the evolution of small changes over time. It had to be, all the pieces have to be there to start with. Argument number 3, the complexity of protein structure shows that life could never arise spontaneously. Number 4, the laws of physics themselves are fine-tuned to allow life to exist. And so tonight we've been referring to this idea of a creator. And we haven't gone into much detail about who that creator might be or what he might be like. But what we have seen is that the whole universe, from complex organisms like beavers and dragonflies and humans, if you zoom in right down to the laws of subatomic particle physics, every step of the way we can see that it's been clearly meticulously designed. It's been designed with a huge amount of care and a huge amount of attention to detail. Let's think of an example. If you've ever been to someone's house and seen a beautiful piece of handmade furniture, perhaps it might have been a dining room table or a grandfather clock. When you look at that piece of furniture and you consider the huge amount of care and effort required, you can reasonably come to the conclusion that whoever made that piece of furniture didn't do it on a whim. They crafted this piece of furniture with love and with care, and they wanted it to fit a specific place in their home. And when we consider the huge amount of care and the huge amount of attention to detail that went into designing this physical world, might we not reasonably draw the same conclusion that whoever created this world cares deeply about it? Whoever created this world has a specific purpose for it to fulfill. And that is exactly what the Bible tells us about God himself. The example of God's love for his creation. Look at John chapter 3, verse 16. For God so loved the world that he gave his only begotten Son, that whosoever believeth in him should not perish but have everlasting life. On the subject of God's purpose for creation, Isaiah 45, verse 18. For thus saith the Lord that created the heavens, God himself that formed the earth and made it. He hath established it. He created it not in vain. He formed it to be inhabited. I am the Lord, and there is none else. So that tells us that God has a specific purpose in creating the earth, and God wants the earth to be inhabited. And elsewhere in the Bible, we can find quotes that show us that God's ultimate purpose is that all people on the earth will come to know about him and come to understand his ways and to serve him in spirit and in truth. As Habakkuk 2 verse 14 puts it, For all the earth shall be filled with the knowledge of the glory of the Lord as the waters cover the sea. And so the incredible design we see in creation shows us the love of God. It shows us the purpose of God. But what I think it shows us above all else is the immense wisdom and understanding of our Creator. And we can't deny the power of that wisdom because we see it around us. We see its effects around us every day in the behaviour of the physical world. And the existence of that incredible wisdom, that raises an important question for all of us. Because the one who created us and designed us from the bottom up has written the Bible. And that Bible is a manual, and it's a manual that gives us guidance on how to operate the equipment that he has created. It's a manual on how we're supposed to live our lives. And is it not reasonable to suppose that the one who designed this equipment, is it not reasonable to suppose that the designer knows far more about how to operate it than we do ourselves? Is it not reasonable to suppose that God knows far more about how we're functioning, how we are supposed to live, than we do ourselves? And so the question is, for all of us, would it not be worthwhile to read the manual, the Bible that God has provided? And would it not be worthwhile to find out what that Bible says? Would it not be worthwhile to make sure that we're following God's instructions?